A cold shock test is a test in which we shock our new facility piping with cryogenic liquid, such as liquid nitrogen. This allows us to demonstrate that our new piping is ready to accept cryogenic conditions. It's very important that we shock our system with an inert cryogen like liquid nitrogen before we introduce liquid hydrogen and liquid oxygen to the stand. When we introduce these extremely cold temperatures to our piping, it tends to thermally contract and it actually moves. So for this test, what we'll do, we'll go out and we'll mark the pipe supports before the test, so we have an original location of the piping. And then when we introduce the liquid nitrogen, the system will cool down from ambient temperatures all the way to minus 320 degrees. So during the cryogenic conditions, we'll mark the piping again to see how much it moved. That allows us to see that our piping was appropriately designed, because the piping is designed to be somewhat flexible and to move. After the test, when the piping warms up, we go back through the pipe supports and make sure that the piping has moved back to its original location or safe location. And we verify that there's no binding up against railing or grating that the pipe's going through. And this is very important before we introduce liquid hydrogen and liquid oxygen, which are flammable and combustible. Once all of the pipe is filled with the liquid nitrogen, the pipe will become frosty. There'll be a layer of frost all along the piping. I've really enjoyed being a part of the A1 activation team. We have a great group of people to work with. They're all very dedicated. We've encountered a few obstacles along the way, and each time we come together, we work together to work through it and get past it. Once this cold shock is complete, we will be well on our way to installing an RS-25 engine on the test stand, and that's very exciting.